Force and laws of motion. Learning about various types of forces. When we want to open the door, we have to push the door handle. And when we want to close the door, we have to pull the door handle with our hand. This means that to move a body or an object, it has either to be pushed or pulled. A push or pull on a body or object is called force. Forces are used in our everyday actions like pushing, pulling, lifting, stretching, and pressing. Study the effect of force. A force can move a stationary body. For example, the force of an engine can move a stationary car. A force can stop a moving body. For example, the force of brakes can stop a moving car. A force can change the speed of a moving body. For example, suppose we are moving on a bicycle at a certain speed. Now, if someone pushes the moving bicycle from behind, then the speed of the bicycle increases and it will move faster. On the other hand, if someone pulls the moving bicycle from behind, then the speed of the bicycle decreases and it will move slower. Thus, a push or a pull can change the speed of a moving bicycle. A force can change the direction of a moving body. For example, in the game of carom, when we take a rebound, then the direction of a striker changes. This is because the edge of the carom board exerts a force on the striker. The force can change the shape and size of a body. For example, if we take a light spring and pull it at both the ends with our hands, then the shape and size of the spring changes. We will now discuss various types of forces. If the resultant of all forces acting on a body is zero, the forces are called balanced forces. If the resultant of all the forces acting on a body is not zero, the forces are called unbalanced forces. Balanced and unbalanced forces. Shows a wooden block on a horizontal table. Two strings, X and Y, are tied to the opposite faces of the block as shown. If we apply a force by pulling the string X, the block begins to move to the right. Similarly, if we pull the string Y, the block moves to the left. But if the block is pulled from both the sides with equal forces, the block will not move. Such forces are called balanced forces and do not change the state of rest or of motion of an object. Now, let us consider a situation in which two opposite forces of different magnitudes pull the block. In this case, the block would begin to move in the direction of a greater force. Thus, the two forces are not balanced and the unbalanced force acts in the direction of the block moves. This suggests that unbalanced force acting on an object brings it in motion. What happens when a person tries to push a box on a rough floor? If he pushes the box with a small force, the box does not move because of friction acting in directions opposite to the push. This friction force arises between two surfaces in contact, in this case, between the bottom of the box and the floor's rough surface. It balances the pushing force and therefore the box does not move. The person pushes the box harder, but the box still does not move. This is because the friction force still balances the pushing force. If the person pushes the box harder still, the pushing force becomes bigger than the friction force. Therefore, there it's an unbalanced force, so the box starts moving. First law of motion. By observing the motion of objects on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them. He observed that when a marble rolls down on an inclined plane, its velocity increases. The marble falls under the unbalanced force of gravity as it rolls down and attains a definite velocity by the time it reaches the bottom. Its velocity decreases when it climbs up, shows a marble resting on an ideal frictionless plane inclined on both sides. Galileo argued that when a marble is released from left, it would roll down the slope and go up on the opposite side of the same height from which it was released. If the inclination of the plane on both the sides are equal, then the marble will climb the same distance that it has covered while rolling down. If the angle of inclination of the right side plane were gradually decreased, then the marble would travel further distance till it reaches the original height. If the right side plane were ultimately made horizontal, that is, the slope is reduced to zero, the marble would continue to travel forever, trying to reach the same height that it was released from. The unbalanced forces on the marble in this case is zero. It thus suggests that an unbalanced force is required to change the motion of a marble, but no net force is needed to sustain the uniform motion of the marble. Newton's first law of motion. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with uniform speed unless it is compelled by an external force to change its state of rest or of uniform motion. The tendency of a body to remain at rest, or if moving, to continue moving in a straight line is called inertia. Newton's first law recognizes that every body has some inertia. Inertia is that property of a body due to which it resists a change in its state of rest or of uniform motion. Law of inertia can be explained on the basis of certain experiences that we come across while traveling in a motor car. We tend to remain at rest with respect to the seat until the driver applies a braking force to stop the motor car. With the application of brakes, the car slows down, but our body tends to continue in the same state of motion because of its inertia. Sudden application of brake may thus cause injury to us by impact or collision with the panels in front. Safety belts are worn to prevent such accidents. Safety belts exert a force on our body to make the forward motion slower. An opposite experience is encountered when we are standing in a bus and the bus begins to move suddenly. Now we tend to fall backwards. This is because the sudden start of the bus brings motion to the bus as well as our feet in contact with the floor of the bus. But the rest of our body opposes this motion because of its inertia. When a motor car makes a sharp turn at a high speed, we tend to get thrown on one side. This can again be explained on the basis of the law of inertia. When an unbalanced force is applied by the engine to change the direction of motion of the motor car, we slip on one side of the seat due to the inertia of our body. Activity. We take a glass tumbler and place a thick square card on its mouth. A coin is then placed above this card in the middle. Let us flick the card hard with our fingers. On flicking, the card moves away, but the coin drops into the glass tumbler. Let me explain how it happened. Initially, both the card and the coin are in a state of rest. Now, when we hit the card with our fingers, a force acts on the card and changes its state of rest to that of motion. Due to this, the card moves away from the mouth of the glass tumbler. A force of a flick, however, does not act on the coin, continue to be in the state of rest due to its inertia. And when the card on which the coin has been placed moves away, the coin falls into the glass tumbler because it prefers to maintain its state of rest due to inertia. Inertia and mass. Resistance is offered by an object to change its state of motion. If it is at rest, it tends to remain at rest. If it is moving, it tends to keep moving. This property of an object is called its inertia. All bodies do not have the same inertia. We know that it's easier to push an empty box than a box full of books. Clearly, heavier or more massive objects offer larger inertia. Quantitatively, the inertia of an object is measured by its mass. We may thus relate inertia and mass as follows. Inertia is the natural tendency of an object to resist a change in its state of motion or of rest. The mass of an object is a measure of its inertia. Summary. First law of motion. An object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. The natural tendency of objects to resist a change in their state of rest or of uniform motion is called inertia. The mass of an object is a measure of its inertia. Its SI unit is kilogram. Force of friction always opposes motion of objects. That is all in this topic. Let us learn Newton's second law of motion in our next topic. So keep learning.